All right, we're back. We're knocking out some CodingBat practice, looking at stuff out of Array-2, which of course require one loop, it says here. We're actually going to get started on sum 67. You see it is tucked in pretty early. I'm kind of laughing because this is a difficult problem relative to the rest that you'll see in this video. So I'm surprised that CodingBat has put it this early in Array-2. So it says, return the sum of the numbers in the array. Easy. Except ignore sections of numbers starting with a 6 and extending to the next 7. They say that every 6 will be followed by at least one 7, guaranteed. Return 0 for no numbers. This is supposed to be a one loop section. I inherently would say like this would be like a 2-loop problem, right? We're going to loop through, and then the moment that we find a 6, we kind of start a sub loop. We start looping again. We have an inner loop, and we keep going until we find the 7, and then we kind of pick back up with our outer loop. That is one approach. I can code that one. It's a little messy, a little bit harder to follow, in my opinion. And in order to keep this just with one loop and a little bit easier to understand, we're going to use a Buoyant approach. What do I mean? Well, the moment that we find a 6, we're going to kind of enter a state where we are ignoring numbers. And we'll keep going, right? We'll keep iterating under this state where we're ignoring numbers until we hit a 7, and then we'll switch back and we'll begin adding to our sum again. So I'm going to need a couple of variables in order to do this. I'm going to start out with a sum, right? Because we do need to find a summation of all the values, except the ones under that ignore state. And then I'm going to bring in a Boolean called ignore. Now, starting out, we're not ignoring numbers. We're not ignoring numbers until we encounter a 6. Okay, so initially this is false. All right, I'm ready to start looping. I'm going to create a for loop. Starting at index 0, as long as I is less than nums.length, I++. Again, I like starting with a standard for loop and then seeing, do I need to edit it later? As we're going to see, we don't need to change this one at all. Our standard for loop is going to work just fine. This one can actually also be solved with a for each loop, and I'll also show you that solution. Okay, so basically, if we are not under the ignore state, we are free to add the current number to our sum. Sum is going to become what it was plus nums at I. Now, this, of course, can be shortened using a shorthand assignment operator. It's the same thing as saying sum plus equals the current element, right? So we're going to loop through. If we are not in the ignore state, we're just going to add the current element. Okay. Now, there needs to be time periods where I enter the ignore state, right? So I'm going to use this one as an example. Start out, our sum is 0. We're going to check to see, are we in the ignore state? We'll add a 1. Are we in the ignore state? No. We'll add the 2. Are we in the ignore state? No. We'll add the other 2. That would put us at a sum of 5 so far. At this moment, I would hit a 6. And my ignore state would become true as a result. And it will stay true as we progress. Once we hit the 7, that's when it would go back. It is possible that there would be more elements after it. In this particular example, 7 just happens to be the last element. So if I am not in the ignore state, we just add the current element. Now, if I am looping and I encounter a 6, that's when we should enter the ignore state. And I'm putting this before the summation, right? Before I add to my current, before I add the current element to my sum, because we don't want to actually add the 6, right? Take a look back at this example. Ultimately, the result should be 5, indicating to me that we are adding just these 3 elements together. The 6 should be ignored, but also the 7 should be ignored. That's actually important. Okay. So I'm putting the statement first because this is going to turn into an else if. I'm going to loop. If the current element is a 6, I'm going to enter the ignore state. That is, ignore is going to become true. Notice that if I just left this as independent if statements, I guess if we just set it to true there, we wouldn't have an issue. It still gets checked. It's still more efficient to make this an else if. Why? The only way that I check this to add to our sum is if this is false. That makes it more efficient. If this is an independent if statement, even if this is a 6, I'm still going to check this. That's inefficient, right? So the else if is better. Right? I'm looping. If the current element is a 6, I will enter the ignore state. However, if I am not in the ignore state, we'll add the current element. Now, this would put us in the ignore state, but we need to come out of it at some point, right? Whenever we encounter a 7. So to check for the 7, I'm going to add to this logic tree, right? If the current element is a 7, I want to leave the ignore state. I want my ignore to become false. Okay. So this is going to be the gist of it. And I think this will get us really close. There'll be some test cases and we'll talk about what's happening. But as I'm looping, if the current element is a 6, I will enter the ignore state, right? That'll put us in an ignore state where we don't add elements until I encounter a 7 and leave the ignore state. Okay. I'm going to return my sum after the loop is over because we have traversed the entire integer array. All right, I'm ready to get some examples flowing. Let's take a look at this one and what happened, what went wrong. Yep, that was the one that went wrong, right? They expected 18. I gave them back a 4. All right, starting out, my sum is 0. Ignore is false. And the last thing I'm interested in is I, right? I've declared and initialized my sum. I've declared and initialized ignore. I'm at this part where I gets created and it has a value of 0, putting it right there. I'm going to ask, are we in bounds? We most certainly are, just getting started. All right, we're going to ask, is the current element a 6? No, it's a 2. Is the current element a 7? Nope, it's a 2. Are we not in the ignore state, right? Ignore has a value of false. This will take the opposite of that, meaning true. We are not in the ignore state. Because this is true, we'll enter the body where we add the current element to our sum. Sum is now 2. We have an I++. Oh, I don't know why I should represent that with an I. Okay. I is now 1. We'll ask, are we still in bounds? We are. Is the current element a 6? Nope. Is the current element equal to a 7? Yes. We'll set ignore to false, which doesn't really do anything. So we're okay so far. But because of that, right? Because I executed this, I will skip this. Maybe that's a reason to leave this as an if statement. I actually don't know if that'll fix our problems, by the way. Oh, no, that made more red. We don't want to do that. What it means is I need to basically add to this, right? The only time I want to set ignore to false is if I am currently in the ignore state, right? This is supposed to trigger after we have entered the ignore state, and then we finally encounter a 7. What's happening is I was on this element. I asked, is it a 7? It is. And that causes me to skip the summation. But I actually do want to add this 7 to my sum because I'm not currently in the ignore state. So I'm going to simply add to this condition, this logic branch. The only time I care about if the current element is a 7 is if I am currently in the ignore state, right? So if we're in the ignore state and the current element is a 7, then I want to set our value back to false. And you see that is a correct solution. I still want to walk through the code from the very beginning. We create sum, it has a value of 0. We create ignore, it has a value of false. We're now here where we create I, and it has a value of 0, putting us at this very first element. We'll ask, are we in bounds? Yes. Is the current element a 6? No. Are we currently in the ignore state? Is ignore true? No. All right. Because this is false, I have and. I don't even need to check the right-hand side. That will trigger short circuit evaluation, which means the whole thing is false. I can just continue on in my logic tree, right? Are we not currently in the ignore state? Well, ignore is false. So not ignore is going to be true. Yes. All right. So I will add this to my sum. I thought I set that back to 0. Sum is now 2. That's the end of the iteration. We do an I++. Whoa, where'd my I go? Is I still in bounds? Yes. Is the current element a 6? Nope. Are we in the ignore state? No. Not even going to check the right-hand side. Okay. If we're not in the ignore state, we'll add the current element. It's a 7. So now our value is 9. That's the end of the iteration. We come back up, do an I++. We're now here. I'm replacing it with a space. Are we still in bounds? Yes. Is the current element a 6? Yes. Set ignore to true. Okay, because this was true, I'm going to skip all the other things. That's the end of the iteration. We do an I++. We're now here. Are we still in bounds? Yes. Is the current element a 6? No. Are we in the ignore state? Yes. Is the current element a 7? No. Because we are in the ignore state, this will be false, right? Ignore has a value of true. Not true is going to be false. Because it is false, I will skip over this. We are not going to add this element because we are in the ignore state. I will do an I++. There we go. We'll ask, are we in bounds? Yes. Is the current element a 6? It is. All right, we'll set ignore to true. Cool. Because this executed, I will skip over these 2 branches of our logic tree. We'll do an I++. We're now here. Are we still in bounds? Yes. Is the current element a 6? No. Are we in the ignore state? Yes. Is the current element a 7? Yes. Set the ignore state back to false. Because I executed this branch, we'll skip the remaining branches, which includes this one. We do an I++, right? We are back. We're no longer ignoring elements. We're going to ask, is I still in bounds? Yes. Is the current element a 6? Nope. Are we in the ignore state? Nope. Because we're not in the ignore state, we will add the current element to our sum, giving me an 11. I have an I++, puts me here. Are we still in bounds? Yes. Is the current element a 6? Nope. Are we in the ignore state? Nope. Because we're not in the ignore state, I will add the current element, bringing us to 18. We do an I++. We'll ask, are we in bounds? Nope. So I will exit the loop. The only thing left is to return our sum, which has a value of 18. I fat fingered, sorry. I didn't do math poorly. I just fat fingered. And that was our answer, was the 18. Okay. That was way harder than the next couple of problems that you're going to see. It could be done using using nested loops. I'll do that solution in just a moment. I don't recommend it. This is a little bit more intuitive, and believe it or not, but it still is difficult. Now, ultimately, I'm just using the current element, the current element, the current element. We don't really care about the index. And because we don't care about the index, this could be replaced with a for each loop, which I will plug in now. Okay. We're ultimately looping through nums, which is an integer array. As such, I'm going to say for each int, which we'll refer to as whatever. I recommend E, which is short for element, in nums. Okay. Keep in mind we're talking about E as in an element. I do not recommend I. That is going to confuse you so much. Okay, because I is kind of indicating index, but that is not what the for each loop is simplifying. Now, everywhere where we're referring to the current element just simply becomes E. Right? These 3 spots. instead of saying nums at I, the current element, I'm going to say E. Nums at I becomes E. So this is what a for each loop would look like, where we've cleaned up, we've reduced a little bit of the syntax here. And in theory, this is supposed to be clean. Really, I just want to get some more for each loop practice in by showing you what that would look like. Okay. I'm going to show you the other nested loop approach. The only advantage it really has, which I don't even think it's that much of an advantage, is that we don't need the Boolean. Basically, whenever we encounter a 6, I'm just going to update my index until we hit a 7. Okay. It's a little awkward because I'm going to be modifying I inside of the body, which is typically not a good approach, but we'll get rid of the Boolean. I'm going to scrap this for now, right? So I'm starting here with a loop. We'll leave our comment because we'll end up using this as a test case, and I'll show you how it works. So I have a standard loop. I'm starting in index 0. We're going to go through the whole array. If the current element is a 6, I'm effectively entering an ignore state, where what I'm going to do is just keep increasing my index until I encounter a 7. Okay, so if I encounter a 6, I'm going to start looping. And I'll say while the current element does not equal a 7. I++. Okay. If I manage to hit this else, what it means is that the current element wasn't a 6. We're not in the ignore state, and so I'm going to add it to my sum. All right, this is a bit more concise, but it's a lot more convoluted. And ultimately, like one thought you could have is getting rid of the else. But as we're going to see, our last let's just loop through, and you'll see why this is inside of the else instead. Okay, my code, I got this array coming in. We create sum. It starts out at 0. I then create I, and it's at 0. We'll ask, are we in bounds? Yes. Is the current element a 6? Nope. Okay, I'll hit this else where I add it to my sum. Sum is now 2. Right? We'll do this I++. We're now here. Is the current, we'll ask, are we in bounds? Yep. Is the current element a 6? Nope. I'll add the current element to my sum. Sum is now 9. We do an I++. We're now here. We'll ask, are we in bounds? Yes. Is the current element a 6? Yes. Okay. While the current element is not a 7, I++. Well, the current element is not a 7. It's a 6. So I'm going to do an I++. That puts me here. This loop is going to keep going. While the current element is not a 7. It's a 2. It's not a 7. So I++. While the current element is not a 7. I++. While the current element is not a 7. Okay. This is now false, right? Which means I don't do this last I++. If this statement was not an else, right? If I just had it here out the open, we would then proceed to add the 7 to our sum incorrectly. That's why the else is here, right? I will skip this else because ultimately this if was true. That's the end of the iteration. The last thing that happens is we do an I++. Notice that we did not add the 7 and we effectively skipped it correctly. We'll ask, are we in bounds? Yes. Is the current element a 6? Nope. Add it to our sum. I++ puts us here. Are we in bounds? Yes. Is the current element a 6? Nope. Let's add it. That's how we get our 18. Now, this looks a little bit more concise, a little bit cleaner, but it is, in fact, using nested loops, right? I ultimately have a loop inside of a loop, which is not naturally intuitive for students. And realities are this section says it's only supposed to require one loop. So You may look at this and think, oh yeah, I like that easier. That's good, right? If you think this is easy and intuitive to you, great. I want to be able to show you multiple ways to solve these problems because that's the fact of the matter. There's multiple ways to solve lots of problems. So let's move on. Hopefully you've stuck it out. The next few are significantly easier compared to what we just accomplished. Given an array of ints, return true if the array contains a 2 next to a 2 somewhere. Okay, so we're going to loop through. With each iteration, we're going to ask, is the current element a 2? If so, we'll check the one next to it. If that's also a 2, we can stop our search there. The fact that I can kind of just stop my search at any moment means I don't need the Boolean variable in advance. Just the moment that we encounter our situation that we're looking for, boom, we found it. We can stop our search. If I manage to go through the entire integer array and that never occurs, that's when I'll return the other value, which would be a false value. I'm going to use a for loop here. Okay. Oh my gosh. Go away. So with each iteration, I'm going to ask, is the current element a 2? If it is, I want to check the one next to it on this exact same iteration. And nums at I plus 1 is also a 2. If this is true, I have found a 2 next to a 2. I'm done. I can stop my search. Return true. We found it. If we manage to go through the entire array, that is, this loop is finished, right? This loop is traversing the entire array. And if I'm still here, that means we never found our 2 next to our 2, so we return false. Okay, this is going to have some slight issues, and we'll talk about why. Yikes, index out of bounds issues. Okay, what's going on? How could I possibly get an index out of bounds? Well, this plus 1. That's sus. How are we going out of bounds? Well, we're going to loop through. And particularly here at the very end, we find a 2, right? We would say, is the current element a 2? Yes. Okay, what about the one next to it? That puts us out of bounds. Okay, simply put, because I'm doing a plus 1, I can stop a little bit early. I can do a minus 1. And logically, this should make sense. The only time I could have a 2 next to a 2, like the last possible scenario, is at this index, like one off from the end, right? If I'm here, well, obviously I can't have a 2 followed by a 2 because there's no more elements. So why even go that far? I want to stop when there's 2 elements left, and that is what the minus 1 will ultimately do. You see we have a correct solution here. I'm not going to walk through one because I think visually that should make sense. Let's go to the next one. Lucky 13. Given an array of ints, return true if the array contains no 1s and no 3s. Okay, I'm going to look at some of these examples real fast. So this one doesn't have a 1 or a 3, so that's true. This one, we get false because we have a 1 and a 3. Okay, so what I'm a little confused on is, do we need both? Neither. 1. If I look at this last example, we see it has a 1 and we get a false value. So we're going to get false if there is a 1 or a 3. Simply put, I'm going to loop through the integer array, which with each iteration, I'm going to ask, is the current number a 1? Is it a 3? If it is a 1 or a 3, I'm going to peace out. If I manage to go through the entire array and we're still here, that means I did not encounter a 1 or a 3. So we're going to return a true value. I'm going to start looping. Oh, one thing I want to say before I get too deep. This last one. Oh, did I lose? Oh, I did. Next. This sum 22 that we did, because I did this, right? Because I need my index because we're doing an I plus 1. Because of that, because I need the index, I need to refer to the index. That means I cannot use a for each loop here, or it's not a good idea. It's not impossible, but that just really defeats the point of a for each loop. This is not a standard loop, and therefore the for each loop does not make sense, right? It's not standard because I'm stopping one iteration early. All right, that's all I want to say. So the reason I thought about that is because this particular problem, I'm not going to need to check an index next to an index. We'll actually be able to use a for each loop here. I'm going to lead with the for loop solution. Here is a standard loop. With each iteration, I'm going to ask, is the current element a 1? Is nums at I a 1? Or is nums at I a 3? If either of these are true, that means I have a 1 or a 3. And in those cases, I want to return false. If I manage to go through the entire array, and this never happens, we're still here, I can safely return true. Okay. I'm about to turn this into a for each loop in just a moment, but before I do, I kind of want to ask, right, we're returning a Boolean, and you've seen me do some problems where I just do it at the point of return. Why can't we just do this? I want you to think for a moment. The problem with doing this is that we could just stop our search, right? I'm going to hit the go button, and you see that there's a lot of red. The problem with this is that we are going to return a value on the first iteration no matter what. I haven't checked the entire array yet, right? This very first iteration is going to return a value. True, false, it doesn't matter. I'm only going to check one element as a result, right? So I only want to return a false value if I happen to find a 1 or a 3, if the current element is a 1 or a 3. Okay, so here I'm just referencing the current element. Here I'm just referencing the current element. This is a standard loop. As such, I can replace it with a for each loop. We're looping through nums, which consist of ints. This is an integer array. I will say for each int, the individual elements, their data type is int, right? This is not an index. This is the element. For each int, which I'll refer to as E, in nums. Okay, this E syntax is ultimately replacing the current element. So this is what our loop looks like. Okay, this for each loop, I think, does a better job of making it a little bit more concise, right? Very minimal code to complete our problem. Let's take a look at the next one. Given array events, return true if the sum of all the 2's in the array is exactly 8. There we go. Okay, so I need a sum, but we're only going to add to it if the current element is a 2. I'm going to start looping through. And with each iteration, I'm going to ask, is the current element a 2? Is the current element, that is nums at I, a 2? If it is, I want to add it to my sum, right? We can do sum plus equals the current element. That makes a lot of sense to me. But because I've already verified that it is a 2, you could just say 2. You know the current element is a 2. You could just add 2. Right? After the loop is over, I have checked every element. Whatever is stored in sum should be the summation of all of the 2's, just the 2's. I need to know, does that equal 8? Right? Effectively, it's this. If our sum is exactly 8, I'm going to return true. Otherwise, I'm going to return false. Right, we'll see that we get a correct solution, and then I'm going to talk about some ways that you can change this. Now, ultimately, this is what I'm talking about with returning the value that is produced by this relational operator. I'm using it as a true or false value here in the body of the, or in the condition of the if statement. I could just return whatever the result is, right? Because if this is true, I give it a true value. If it's false, I'm returning a false value. So it all hinges on this statement. Well, we could just do that at the point of return. I don't need these if-else statements. I could just return this. This is outside the loop, right? So it only happens one time, but I am returning the true or false value produced by this relational operator. Okay. Ultimately, I didn't need the index. This is a standard loop. You guessed it. We can use a for each loop, which means I will be replacing the current element with E. And look how concise this is. Right? Not a lot of text in my field of view. If another programmer that is familiar with for each loops encounters this, they just know, oh yeah, you're just going through nums from beginning to end. And that is the reason that for each loops are a thing. Okay. We're going to pause there. That was some good practice. I'll see you in the next one.